hopefully, what I was looking for on this is you'd see, you know, well, what could I take the derivative of that would give me 2t plus 4? So what would that be? T squared plus 4t. Everybody see that? Okay. But hopefully you recognize that when I plug 3 into this, I'm not getting 11, right? I'm getting, what's that going to be? I'm getting 9 plus 12, 21, right? And so what are we going to have to do to make it come out to 11? Subtract 10. And realize if we subtract 10, when we take the derivative, this is my position function. When we subtract 10, or we take the derivative of this, what happens to that minus 10?
Goes away.
It goes away, right? So we don't have to really worry about it, right? But this is also a reason why we can never know, just from the velocity equation, we can never know what the position is, right? Because there was always some sort of constant that could have disappeared and gone away, right? All right, so what we're going to be talking about today is this process of reversing the derivative, which is called anti-differentiation or indefinite integration, okay? And so you're going to see this notation right here. This, notice, it's a little different from the one we've been using. We saw this symbol before, right? Ah, interesting. We're seeing it again in something that seems somewhat different, right? So we have this symbol right here, but there's no bounds on it. So this has no bounds. That's when we talk about indefinite integration. That's going to have no bounds. It's not going to have a to b or 0 to 5 or anything like that on it. But when you do that, that's going to be the antiderivative. That means take the antiderivative, or basically reversing the derivative, right? And so the derivative, so the antiderivative of f prime of x is just f of x plus c, okay? And so forth and so on. The second derivative, antiderivative, that would just be f prime plus c. And the antiderivative of f of x, a lot of times you'll see this in textbooks, or you'll see if you're looking at videos online or anything like that. Sometimes they refer to the antiderivative of f as capital F, okay, is the way that goes, right? And so what we've realized is we should be able to take the derivative of our answer and get right back to what we call the integrand, okay? So this is what we're taking the indefinite integration is called the integrand, but you're not going to have to know that. But you should be able to get back to this, right? You should be able to get the derivative of f of x is f prime of x, okay? Any questions over that? Right? Why do you think we need that plus c? So why is that plus c here in all these again?
Constant.
It's that constant, right? When you take the derivative of it, that disappears, right? So the same idea, that's like that negative 10. So when we take the antiderivative, we're going to have a plus c on every antiderivative, okay? That makes sense? All right, so I want you to try these real fast. See if you can't figure out what these might be. What would f of x be? So find f of x for each of those. See if you can't figure that out. Should be able to take the derivative of this and get that. First term's a little tricky, huh? No, easy. What should it be? X to the what?
1.
Do 1/5?
1/5 x to the 5th.
X to the 5th. Not that hard. Right? So you should be able to take the derivative of all of these and get that. All right, how about this one?
E to the x.
E to the x
Plus
sin
sine.
x, right? Let's see. So if we took the derivative of this, we would get that right there. Okay? Take the derivative. So the hard thing is going to be, when we take the antiderivative of cosine, it's going to be positive sine. Take the derivative of cosine, it's negative sine. Getting those straight in your mind, that's just going to happen. Okay? So apologize for that. All right, so there's a rule. So what do we think the rule is going to be? What do we see the rule? What's happening to these exponents? They're going up 1 power, right? So instead of taking the derivative where you dropped it 1 power, basically doing the reverse. It's going to go up 1 power. And then what do we have to multiply in front by? So in the derivative, we took the exponent, we multiplied it in front to the coefficient in front, and we dropped the 1 power. Correct. So 1 over the new exponent, right? So we're basically going up 1 power and then multiplying by the reciprocal of the exponent, the new exponent. Okay? And so on the next page, I think it explains that. So antiderivative power rule. This is it. Okay? So if you were taking the antiderivative of x to the n, what we're going to do is we're going to go up 1 power with the exponent, so x to the n plus 1, but then times the reciprocal of that new exponent, which is really 1 over that new exponent, right? So here it tells you in words. In other words, first raise your exponent by 1, then multiply the coefficient by the reciprocal of your new exponent, and then lastly, add plus c, for the constant that could have been there. That when you take the derivative of it, you should always be able to take the derivative of your answer and get back to what we call the integrand, okay? What's inside that integral function, okay? There is one exception. Because notice, if we try to do that same power rule with x to the negative first, we go up 1 power, we get 0. What is 1 over 0? Undefined. So it doesn't work for 1 over x or x to the negative first. That's the only exception. But we did recall though, if we take the derivative of natural log of x, we got 1 over x. So if we're going to take the antiderivative of 1 over x, it'll come right back to natural log of x. Okay? So what we find here is the antiderivative of 1 over x is going to be natural log, and it's going to be the absolute value of x. Okay? And the reason the absolute value is there is because this domain for this function is all real numbers except 0. Logarithms are only positive numbers, like only positive. So this allows us to actually match the whole domain. And I'm not going to go into, like, there's some symmetry based off of this graph that makes this work. And then it works for all values. And so that turns out to be the derivative of 1 over x. That's the only exception. Okay? Questions over that? Oh, I'm already mad at myself now. Yep, I'm doing it. Okay. I'll have to change that before y'all start working. I already know on the answer key, I made the new questions for you guys for this year for antiderivatives. I didn't put absolute values on my natural log antiderivatives. I know, I already knew. I just realized, I'm like, why did I not do that? That's so stupid. All right, let's go ahead and look at this one. So if we're going to find these antiderivatives, so using that power rule, we're going to go up 1 power. So it's going to be x to the, this is the way I like to do it. I just think about, okay, 1 x to the 4th, and then times 1/4. And you can actually think about the 4 there. You can also skip this step right here. But I'm going to show you on the first one all the steps, right? So it's 4 times whatever the antiderivative of that x to the 3rd is, right? So that's what's going to happen this over here. We're going to raise it 1 power to 2, and then times 1/2. And then 7, it's just going to be 7x. So just like the derivative of 7x is 7, it goes like this. This is really x to the 0 power. It's really what's happening. And so it becomes x to the 1st power times 1, and then plus c. And so you can simplify this. It's just going to be x to the 4th plus 1/2 x squared plus 7x plus c. Questions over that? Do the next one. Make sure, see if you can do that one. Make sure you know how to do it. If anybody has any questions, please ask. Did y'all get that? So we went up 1 power times the reciprocal, so 3 over 6, which is just 1/2, 7/4, and then just x. be the antiderivative of 1. What are we going to have to do with this? What do you think we're going to have to do first? Fractional exponents, right? So we're going to end up having to rewrite this as the integral of x to the negative third. And then what is this? So this is x to the 1/4, right? We have to do that. Here's what I want you guys to make sure you don't do. And this will definitely, on the AP exam, they always put this in answer choice. They always put natural log of x cubed as an answer choice. That is definitely wrong. That is not something we can actually take the antiderivative of this, right? The natural log of x cubed does not equal, if you take the derivative of that, it does not equal 1 over x cubed. That's not without the chain rule, right? So that's not correct. So what we need to do is we need to just do the same thing. So x to the negative second times negative 1/2 plus x to the what power? What do you think this was going to be? Up 1 power. 5/4 times 4 over 5 plus c. Now, I don't want you guys leaving this with negative or fractional exponents. We need to get more comfortable. I still feel like many of us are still struggling with our negative and fractional exponents. So we're going to rewrite this as negative 1 over 2x squared plus 4 over 5, and this would be the 4th root of x to the 5th. What's that? 5/4, right? 5/4. Yeah. We have to multiply by the reciprocal of it. So if we were to take the derivative of this, it's going to cancel out. That makes sense? And then we drop 1 power. Everybody good? Do we got any questions? All right, let's take a look at this next one. Here's the deal, guys. So just like with derivatives, was it okay to just take the derivative of 2 factors separately and then add them together? No, it was not okay. Here's the good news. The good news is there's not really a product rule. There kind of is going to be a product rule, like second semester for BC, for you guys. Not for AB, but for BC. Kind of going to be a product rule, but not exactly like this. But what you're going to have to realize is we need to simplify this first before we take the antiderivative. So we're going to have to say this is the same thing as the integral of x to the 4th, and then minus, what is this going to be?
Wait, what?
Distributing.
Oh, okay.
This, so distribute.
Okay.
Simplify it.
So that's what you x to the negative third.
X.
Wait, no. You said x to the
X to the negative first. I'll go ahead and write it out since I see that I've confused people. Here we go. We're distributing it. And then this would end up being x to the 4th minus, this would just be 1 over x. And so when I take this antiderivative, we're going to end up with what? X to the 5th minus natural log of the absolute value of x. Yeah, plus c. So you're going to have to make sure you can't have any factors. You're going to have to multiply them out first. Yes? You can. Either way, whichever way it makes you recognize that it's going to be natural log. Okay? And I would suggest this when we get into the U substitution. You're going to end up seeing that it's going to it's going to be easier to see it this way. All right, this one over here. So here's another great. There's a good news and bad news, right? With this, good news is there's no quotient rule that we're going to learn for this. So if you hated the quotient rule with derivatives, guess what? We're not going to have a quotient. Okay. The bad news is you don't have the option of doing the quotient rule to do this, right? You have to do the algebra. You have to know that you have to be able to split this into 3 separate terms. Okay. And so this is the same thing as. I should have had dx over here. That's terrible. This step right there. So you have to split this in 3 separate terms. And so this is really going to be x squared over x to the 1/2 power plus 3, square root of x. We can do square root of x over square root of x. Those are going to cancel. And then plus 2 over x to the 1/2 power. Okay? And these are just going to cancel right here. And so then we need to simplify this. Make sure this, and what happens whenever we divide, what happens to the exponents? We subtract them, right? So 2 minus 1/2 is really 3/2. So we've got to be good with our properties of exponents. Plus 3 plus 2x to the negative 1/2. We have not taken the antiderivative yet. There should be really a dx out here. Sorry about that. Apologize. We have not taken the antiderivative yet. So sometimes I think students do this step right here and they think, oh, I got the answer. I already did all the algebra and everything. Now we actually have to go up 1 power. So x to the 5/2 times 2 over 5 plus 3x. This one? Which one do you?
Yeah, I got
We
it.
good? Okay. And then the next one, we go up 1 power. So going up 1 power from negative 1/2 is going to be x to the 1/2, but then times 2, so we're going to get 4. Plus C. Yes? No, not yet. Not until I have not seen us demonstrate mastery of fractional exponents yet. So I will say this is going to be 2 over 5. Actually, it would be 2/5. And don't try to like put it in the weird space over here. Make sure it's solidly like this is the square root of x to the 5th. But don't make it confused like it's in some people I think try to play it both ways, like they don't know if it's the numerator or denominator. Plus 3x, and this would just be plus 4 square root of x. Plus. Questions over that? All right, I want you guys to try to do F. Try to do F. So one thing that I think messes students up on this question F is if you write it as 3x to the negative 2nd, you're already lost, right? You've already missed the question. Okay? So realize this x squared, this squared only applies to the x, not to the 3. So it should be 1/3 x to the negative 2nd. And see, that's where most people make the mistake on that, right? And then, so this is how it has to simplify before you can actually take the antiderivative. Okay. Any questions over that? All right, so a few of the special common antiderivatives. What do we think the antiderivative sign is going to be? Negative cosine plus c, right? We're going to take the derivative of this, be negative sign, would come back to equaling sine, right? How about e to the x?
Yeah.
E to the x, that was a nice and easy one, right? E to the x plus c. You got to remember the plus c, though. Some people don't do that. How about cosine? It's going to be sine 1 over x. We just talked about that one. ln natural log the absolute value of x plus c. What do you think about secant squared x? Tangent x, right? And this one I put on here, so tangent x. Why do you think its antiderivative is negative natural log the absolute value of cosine of x plus c?
Because it's 1 over cosine.
So 1 over cosine times what? Times the derivative of the inside function, which is what? Negative sine. Negatives cancel out, and you get sine x over cosine x. Right? So if you were to take the derivative of this, you would get tangent. Okay? What's that? A little bit. I mean, you do have to know these trig identities, though. Yeah, like that sine over cosine equals that. But that's where I just wanted to see that that's where it came from. Okay? Any questions over that? All right, here's what I want you guys to do. I'm going to give you guys about maybe 10 minutes to try to work through some of these. If you have any questions, you can ask. There is going to be a quiz, a short quiz over just this. Later on in the class, we're going to talk about U substitution a little bit. And so it will not include the U substitution, your quiz on Monday. That has its own separate quiz on Tuesday. These quizzes are going to be short. They're going to be like 4 or 5 questions only. So it'll be like 4 or 5 of these questions, ranging from easy to a little bit hard. So this assignment is in Google Classroom. You guys got 10 minutes to work on these. And if you have any questions, let me know. The answers are on Google Classroom. Be aware, I did not put absolute values on my natural log antiderivatives. I'm going to change that, but that may take a little bit. Well, get on that one.